Hello everyone, let us start lecture 14. And our topic remains same. On the basis of mixed potential theory. This explanation of corrosion events on the basis of mixed potential theory, that is the topic, and today we will consider some numerical analysis for two situations. One is when cathodic increases remain same, and second thing is increases but so these two situations will solve some problems. Okay. Now, if we try to solve the first case, and remember the data will take in such a fashion that they will be related, both the problems will be, both the sets cases will be related. Now, if we try to draw the diagram, in fact, here we have to draw log I, capital I. Remember, here we have to consider in the form of current in order to understand the area effect, and our choice of solution, of course, hydrogen evolution is our reduction reaction, pH 3, and so if pH is 3, so this E equilibrium hydrogen equal to minus 0.59 into pH equal to 0.5, and pH is nothing but 3. So, I can multiply by 3, which is becoming minus 0.77 volt, and our consideration is the pressure of hydrogen remains 1 atmosphere. Now, if we arbitrarily choose I0 hydrogen over zinc surface equal to 10 to the power minus 11 ampere per centimeter square, I0 zinc over zinc equal to 10 to the power minus 9 ampere per centimeter square. Now, I core of zinc when zinc equal to 1 centimeter square equal to anyhow, when we are talking about small I, it's every time it's with reference to 1 centimeter square, unit area is 10 to the power minus 5 ampere per centimeter square. Then I0 hydrogen on platinum equal to 10 to the power minus 5 ampere per centimeter square. Beta A equal to 0.1 as well as beta C. The only thing is their signs will change. In case of beta C, there will be minus, and in case of beta A, there will be positive. So, I am just writing plus minus volt for decade of current density, and then and these two values will not change when we convert it into log current scale, then that means this becomes volt per decade of current change. Now, if we try to plot them, so this becomes I0 hydrogen over zinc, and this becomes my I0 zinc over zinc. So, this is 9. So, this point will be relative position will be like this, and then this point becomes my I0 hydrogen over platinum. Now, if we try to see so this is I core zinc when it is immersed in that acid without connecting it to the platinum area platinum, and if we connect it with the platinum, so it will also have its own plot, and then we have to add, as per the mixed potential theory, we have to add it. This is the total. I am not indicating that because you please go back and then check how we have drawn this. So, now this will be extended. So, this point becomes my E mix zinc platinum 1 centimeter square area. Now, once we changed it to 100 centimeter square area. So, let us say if I change it to 100 centimeter square in case of platinum, see one case platinum equal to 100 centimeter square, the another case it become and zinc 1 centimeter square, this case 1, case 2 platinum equal to 1 centimeter square and zinc 100 centimeter square. Okay. So, or let us say I make it different, little different. So, I make it 10 centimeter square. Okay. So, once we do that, the case 1 case, so if it is, if this value is 10 to the power minus 5 ampere per centimeter square, so this point would become 10 to the power minus 3 ampere when platinum equal to 100 centimeter square. Please make sure that, please look at the unit what we are using. So, it's here it is ampere. Now, when you do that, we have to have its own plot. This is IC total in ampere equal to IC hydrogen over zinc of 1 centimeter square plus IC hydrogen over platinum 100 centimeter square. Right. Sorry, this is not that part, it is rather this is the, this is IC hydrogen over platinum 100 centimeter square, and then if I do it with the different color, so this becomes my this is the total part. Now, if we extend this one, so it will cut here, this becomes my E mix zinc platinum 100 centimeter square, and zinc here we are not changing. Now, those values if we try to indicate, this is 10 to the minus 5 ampere per centimeter square, and this is 10 to the power minus 11 ampere per centimeter square. This is 10 to the minus 9 ampere per centimeter square, and we have already indicated everything, and this value corresponds to minus 0.177 volt. Now we have to find out E mix zinc. So now if you want to mix, try to find out. So the first thing, let us find out E mix zinc. In order to do that, we just take this line. If we take that line, so E mix minus E, so this is nothing but E equilibrium hydrogen, this is E equilibrium zinc, equilibrium hydrogen equal to minus 0.1 log of IC hydrogen over zinc divided by I0 hydrogen over zinc. Now if we solve it by putting all the values, we will get E mix would be equal to minus 0.6 minus 0.177 equal to 0.-1777. This will be the E mix zinc. Now if we try to solve, now we have to find out E equilibrium zinc, which can also be found out. We have to find out that part. So E mix zinc minus E equilibrium zinc equal to 0.1 log of, we have to take this particular line, IA zinc, IA zinc, I0 zinc over zinc surface would be equal to E equilibrium zinc would be equal to so minus 0.4 minus 0.777 equal to minus 1.177. So that will be the value volt. Okay. So we have found out this point, so I can mention it to be minus 0.7. So these points I can change, it becomes minus 1.177, and this would be minus 0.777. Okay, so now if we try to find out, now let us find out this point if I need to find out. So let's find out E mix zinc platinum when it is 1 centimeter square. If we try to find out, so we have to solve two equations. We have to find out this point. So this point would become 10 to the power minus 11 plus 10 to the power minus 5, which is nothing but 10 to the power minus 5 ampere per centimeter square. So if we solve that, so two equations if I indicate in this fashion E mix single prime, so single prime minus 0.177 plus equal to minus 0.1 log I C total by I 0 total, I can write in this fashion 1 log of I A divided by I 0 total, the way we have done previously. So it becomes, so this becomes E mix prime plus 0.177 equal to minus 0.1 log of IA plus, and then this value is nothing but 10 to the power hydrogen total is nothing but 10 to the power minus 5 ampere per centimeter square, we have seen already. So this becomes 0.5, sorry, this becomes 0.5, and for the anodic part, if we consider plus 1.177 equal to minus 0. This is plus log IA plus 0.9, because we are considering this line and this line. So if we solve that, this is equation 1, this is equation 2. So if we add them, prime plus 1.354 equal to, these two would get cancelled, and then we are getting 0.4. So E mix prime becomes .477. So this becomes, this value becomes minus 0.477 volt. Now we can calculate IA zinc when for this couple of 1 centimeter square, we can do that. So if we take equation 2, so minus 0.477 plus 1.7177 equal to 0.1 log IA by 10 to the power minus 9, because I 0 here I have to take I 0 of zinc over zinc surface. So if we solve this, this is 4, solve this, we will get IA would be equal to 10 to the power 7 into 10 to the power minus 9. So this becomes 10 to the minus 2 ampere per centimeter square. So this is the corrosion rate of zinc when is galvanically coupled. Zinc 1 centimeter square is galvanically coupled to platinum 1 centimeter square. Now when we increase the area of the platinum, so we have to find out, so if we correspond to this, this particular point becomes this, so this becomes 10 to the power minus 3, because we are not changing I 0, capital I 0, because zinc area we are not changing. So 10 to the power minus 11 ampere plus 10 to the power minus 3 ampere, which is roughly equal to 10 to the power minus 3 ampere, because minus 11, because when we change everything to ampere instead of ampere per second, ampere per centimeter square, and then this particular value we can calculate again, the similar practice we can do. So, if we try to find out E mix zinc 1 centimeter square, platinum 100 centimeter square area. So, we have to find out. So, if we assume this is to be E mix double prime, so again we can follow the similar equation solving mode. So, E mix double prime plus 0.177 equal to minus 0.1 log. Now, we are changing everything into capital I, minus 0.3, because here equation becomes 0.1 log IC hydrogen, I would say total, plus I0 hydrogen total. So, this is equal to C. So, I can change it to minus 0.1 log IA divided by I0 hydrogen total. So, this I0 hydrogen total is nothing but 10 to the minus 3 ampere. So, this is one equation. Then another equation, if we consider the anodic part, 0.1 log IA minus, this will become plus, and since the zinc area is not changing, so I0, small I0 is nothing but the capital I0 in terms of magnitude. So, if we solve this again, if we add them, so 2 E double prime mix plus 1.354, this 2 will get cancelled. So, we are left with 0.6. So, E double prime mix equal to minus 0.377 volt. volt. Now, this is I am talking about this point. This is the value we have calculated. Now, if we want to calculate IA, this is 5, this is 6. IA, when zinc 1 centimeter square is connected to platinum 100 centimeter square, if we want to calculate. So, E mix double prime plus 1.177 equal to 0.1 IA 0 zinc over zinc surface. So, this becomes 10 to the power minus 1. If we do that, you will get 10 to the power minus 1, because this is this is 10 to the power minus 1. So, this becomes my corrosion current when zinc 1 centimeter square is connected to platinum 100 centimeter square. Now, if I try to calculate the current density, or corrosion current density of zinc. So, this will be equal to 10 to the power minus 1 ampere 1 centimeter square, because the zinc area has not changed. So, this becomes the 1 ampere per centimeter square. So, now we could see that when, if we try to compare this value and this value, I could see that the corrosion rate has increased 1 order magnitude. Now, this is the part 1 or case 2. This is case 1 and case 2 if we try to see, where zinc area is 10 centimeter square and platinum area is 1 centimeter square. That case, if we plot everything in the red color, so this point will not change for 1 centimeter square area, but once we change to zinc is changed to 10 centimeter square. So, this will come here. So, this becomes 10 to the power minus 8 cent ampere, since zinc is now 10 centimeter square. So, this is to be 10 to the minus 9 into 10 becomes this, and this will also become 10 to the power minus 10 ampere. So, if we continue this, so they will connect here at the same, so here it will connect. Now, this line we have to consider addition of this line and this line we have to consider. So, this will shift little bit on the right side, and we have to continue that 10 centimeter square line to this. So, now we are getting new point this and this. So, let us find out all those 2 points and try to find out what could be the corresponding IA and IA. These 2 values let us find out, because this will be the mixed values, mixed potential. As per the mixed potential, this the theory will be met at this point. At this point it will be met. So, let us find out that. Now, in order to find out, first we have to find out this particular point, and then we go ahead with this. So, if I try to find out the first point, so now we will be considering everything in terms of I, capital I and E, of course. So, now first part is we have to solve. In order to get this point, we have to solve 2 equations. What are those 2 equations? I will just a bit of jump I will do. First part is E mix star. Let us say this point is E mix star. So, if I try to find out this, so E mix star minus 0.177, because this value will not change, this value will remain fixed, volt, this is volt. So, equal to 0.1 if we take this line. So, it will be in terms of area, in terms of current, I C hydrogen over zinc surface, I 0 hydrogen over zinc surface zinc. So, I can replace it with IA log IA, and this one I know 10 to the 10. So, this becomes 0.1.0, and corresponding E mix star plus 1.177 equal to 0.1 log IA, and this becomes plus 0.8. So, if we add them, this 2 will get cancelled. So, this becomes 0.2. So, E mix star 2 equal to minus 1.554. So, E mix star equal to minus 0.777. So, interestingly we could see that even if we increase the area, this E mix is nothing but the same value. Now, we have to find out IA, which can be found out by taking this equation. So, IA, if you calculate, you will see that IA value comes out to be 10 to the power minus 4 ampere. Now, corresponding to IA, if I try to find out 10 to the power minus 4 divided by 10 centimeter square equal to 10 to the power minus 5 ampere per centimeter square. And so, this is the corrosion rate of zinc of 10 centimeter square when zinc only is dipped in acid. Now, we have to find out then this particular point, which let us say make it double star. So, if we do that, then this is let us say 1, then 2, same I will go by, I will try to solve. In this case we solved this line and this line, and now in this case we will solve this line and this line. Now, we have already found out that this point will be this point will be 10 to the power minus 5 ampere only, because if we add this value and I0 when platinum is 1 centimeter square, which is this point, if we correspondingly capital I0 would be same value, because we are not changing platinum area. So, if we add this and this quantity, which becomes 10 to the minus 5 ampere. So, that case we have to again constitute two equations in order to do that. So, E mix double star. So, if I try to solve this line and this line, then I have to again constitute another equation. This is stage 2. E mix, we are trying to find out E mix and IA. First I will try to find out IA when zinc 10 centimeter square is connected to platinum 1 centimeter square. So, if we try to do that, so E mix plus 0.177 equal to minus 0.1. I am not, see, because when we try to the same way, when we try to solve, draw a equation and equation for this line, so we are assuming that the current value does not change, because it is roughly same value, as we have seen that this quantity and this quantity, if we add it, it becomes roughly around the minus 5. So, that does not change. So, and at the same time we are seeing that at this point rate, the current corresponding to the total evolution of hydrogen is equal to the total current corresponding to the dissolution of zinc. So, if we do that, log of IA, and here I0 total is nothing but minus 5. So, it becomes, so I0 total equal to 10 to the power minus 10 plus 10 to the power minus 5 equal to 10 to the power minus 5 ampere. So, 0.5 E mix plus 1.177 equal to 0.1. This is here I am replacing IC total. So, here it will be, this is in the anodic part, this is the cathodic part, plus 0.8, because here I have to consider this line. So, here the point has changed to the minus 8. So, if we add them, plus 1.354 equal to, this 2 would get cancelled. So, this becomes 0.3. So, E mix star double star equal to so E mix double star equal to 1 point minus 0.54 by 2 equal to minus 0.527. So, this is the E mix thing. Then we can take this equation to find out IA. So, 527, if we try to find out IA, so we can solve equation 2, this equation we can solve. So, minus 0.527 plus 1.177 equal to 0.1 log of IA divided by 10 to the power minus 8 ampere. So, then it becomes IA equal to 10 to the power 6.5 into 10 to the power minus 8, which becomes 10 to the power 1.5 minus 1.5 ampere. So, now this is the corrosion current when zinc is 10 centimeter square. So, now corresponding IA, if we try to find out, 10 to the power minus 1.5 divided by 10 centimeter square, which becomes 10 to the power minus 2.5 ampere per centimeter square. This is the corrosion density when 10 centimeter square is connected to platinum 1 centimeter square. Now, let us get back to the corrosion current density when zinc 1 centimeter square is connected to platinum 1 centimeter square. That value was, we have calculated before. So, that value was 10 to the power minus 2. That value was, let me see what was the value calculated. Yes, this was the value we have calculated. So, it was 10 to the power minus 2. So, I could see that IA zinc 1 centimeter square, platinum 1 centimeter square is greater than IA zinc 10 centimeter square and platinum 1 centimeter square. So, it is very clear that the corrosion current density of zinc, if we increase the anodic area, decreases with reference to the value what we have found out when zinc of 1 centimeter square area is connected to platinum of 1 centimeter square area. So, the zinc corrosion rate actually decreases because of increase in anodic area. But if I try to find out corrosion current density when zinc 1 centimeter square and platinum 100 centimeter square, these were the situation. That time corrosion current density was ampere in the minus 1 ampere per centimeter square, which is much higher. So, that means I could see that the corrosion rate of anodic region increases because of the connection of that anodic region to a cathodic region of higher area, but the zinc corrosion rate decreases when it is connected to when its own area increases with reference to the cathodic area. And remember, every time we are assuming that it is uniform dissolution. That situation, and the assumption is, this is one important assumption, all those problems, it is uniform distribution of cathodic and anodic reactions over cathode and anode area, and we are considering uniform dissolution. So, that case we could see that increase in cathodic area is not good for the structural design. Rather, if we have increase in anodic area with reference to the cathodic area, that serves better because the dissolution rate decreases. So, from this numerical solving the problem solving mode, we could see the effect of area factor, and we see the area factor in a better fashion and appreciate it better. Let us stop it, and we will continue our discussion in our future lectures. Thank you.